My name is Mike Fratto, Senior Analyst with 451 Research, and today I'm going to talk about network performance monitoring in modern networks. Network performance monitoring in the enterprise has largely been static because that's how IT was built and that's how applications were deployed. However, with new technologies like software-defined networking, SD-WAN, cloud, and cloud architectures, the network has become much more dynamic because IT has become much more dynamic. The impact of that is performance monitoring now has blind spots. As applications move about the data center, or if an application is moved from an on-premises data center out to a cloud service, there are gaps that open up in performance monitoring. You can't very well stick a hardware probe out into a cloud service. You can find software probes, but it may not be able to collect the same amount of information. In addition, there are now new dependencies when applications are deployed, and applications now are being deployed automatically without human intervention. So it's one more element, network performance management, that needs to be added to the workload, to the workflow, in order to make sure that it gets deployed wherever the workloads happen to reside, and that they actually move with those workloads as well. So the impact is that network performance monitoring needs to become software defined. It needs to become far more dynamic than what enterprises have currently been using. Enterprise IT needs to think of network performance management as an architecture rather than as a set of bespoke, discrete products that they acquire. As an architecture, enterprises are going to think about what kinds of measurements they want to take, what kinds of metrics they want to track for network performance and to assure good quality network performance. They're going to be able to think about where they want to take those measurements and what types of technologies they're going to need in order to get those measurements, whether we're talking wired or wireless or putting probes out into a cloud service. They'll be able to talk about with their performance management architecture how this data is going to be pulled back and analyzed and what kind of system is going to be required. So much like you have an application architecture, a server architecture, a storage architecture, which looks at the totality of those systems, a performance management architecture does the same thing. And equally important, that architecture is going to have to fit in with and integrate with all the rest of the architectures that IT already manages. So get rid of the discrete, bespoke performance management mindset and think architecture and system-wide. The benefit of full-stack monitoring is to provide contextual awareness to enterprise IT of what's happening on the network. With discrete, bespoke components, it's the IT administrator is the glue between all of those particular products. You see a performance issue or a user calls up and says that the network is performing badly or they're having application issues. And so you might look in an application performance monitoring system, and then you'll take the administrator takes context from it and then goes and looks at a network performance management system and then may go look at a packet capture. And it's your IT administrator that becomes the glue. And when they go and they pass off the ball or the workload to somebody else who might be more of an expert in a different field, they're going to have to type out all that context and they're going to have to convey it in some way. There's an awful lot of work. It's really inefficient when you're working in large dynamic IT shops, or even when you're in a smaller IT shop and you just don't have the time because you've got 100 burning fires to go put out. So with full stack monitoring, it's one, looking at the application stack from layer one all the way up to the application and looking side to side, understanding the inventory that's out in the network, understanding the topology that's in the network, both of the physical layer as well as the virtual layer, and having that full view of what's on the network and then being able to very quickly move from one part of the stack to the other part of the stack, maintaining that context. So a user calls in and says they're having bad application performance, or the application seems slow and they can't get their work done. Well, you can take that user information, looking at the application layer, and begin to understand the client and the server and what's happening at that level. And then you can really quickly start to drill down, and you can look at all the parts of the chain that makes up that application and start looking at those metrics. And then if you need to, you can go deeper and you can start looking at what's happening at the hardware layer and understand what that topology looks like. And if it's in a virtualized environment, which in most cases it's going to be, you can understand what's happening at the physical layer and understand what's happening at the virtual layer and start to relate those two layers together because they may look very different. So with full stack monitoring, that's unified into a system, and that doesn't necessarily mean it's all one big monolithic server, but it's an integrated system of different components, then that provides the context to allow IT to very quickly resolve problems and very quickly understand what's happening on the network. And then when they need to, they can pass that ball with full context to somebody else. Machine learning and advanced analytics is going to have significant impact on network performance monitoring. Starting with machine learning, there's so much information that can be collected. A person is just never going to be able to make sense of it. There's a variety of information coming from network sensors and coming from hardware and coming from applications that is just too voluminous. And trying to relate what's happening in one system over here to something happening in a system over here, it's going to be almost impossible. Machine learning is tireless, and the algorithms that are being designed and deployed and tested will be able to start to make sense of what's happening in all of that data and should be able to surface some new insights and some new visualizations for network operators and for enterprise IT to start making sense of what's going on in the network and then to be able to resolve problems. And that's really the goal. Today we have a lot of algorithmic learning, so we know what certain kinds of traffic patterns look like, and those are really useful. But the promise of machine learning is going to be understanding traffic patterns that haven't been seen before, or understanding patterns across IT systems that haven't been seen before. And what that's going to lead to is advanced analytics. Rather than replacing people, machine learning and advanced analytics is going to be a significant augmentation to what you're already doing. So the more sense you can make of the volume of data coming in, the more reasonable the conclusions are that you can make, the better off you're going to be in getting an accurate picture of network performance, and you'll be able to provide better service, and you'll be able to resolve problems much more quickly. Advanced analytics and machine learning is going to have a significant impact in the years to come, and it's going to be really exciting for the performance management space.